Good evening, one and all. So, um, today it's the 12th and the last live session for the course Basic Environmental Engineering, Pollution and Abatement. Yeah, so if you have any doubts also from the previous class, then do let me know. So let me share my screen and let's start with today's class. Yeah, so in this class, basically, we will be uh, talking about, yeah. So in this class, we will be talking about various air pollution management and management of special category of waste, including medical waste as well as you know this electrical waste. So let's start with the session. So starting with the air quality management and air pollution management. So here our aim is to eliminate or reduce the uh, airborne gaseous pollutant, particulate matter, and any sort of other contaminants, toxic contaminants, which are found to cause adverse impacts. Now, in air pollution abatement plan, you can include uh, like so to do that, you need to have some rules and regulations. You need to have some proper planning and a body that governs and that keeps a check on it. So, what could be the plan? So, first, it's the description of area. So, what area it is coming? For example, uh,
Excuse me, ma'am.
yeah,
For the real exam, is the assignment practice and is the theory class which the lectures given studying enough for the exam?
yeah. You can look into the assignments that you are given. Also, the assignments that are solved, like the sample assignment in the class, that you can refer, and
Okay.
similar questions you might get in the exam.
Okay.
Okay. So, if you have any difficulty while solving your uh, tutorial or any assignment, you can put it in this class because this will be the last one.
Yeah. Up till now, yeah, I have clarified the ones before, but for the last one, it was a theory one, so it was not that much.
Okay, okay, sure. Yeah, so here, depending on the area, because residential area might be having different emission, while industrial areas might be having different emission. So first you classify different areas, and then you have emission inventory. Now this inventory is related to any sort of uh, identifying what sort of emission and getting idea of what toxicity it can result into. Then compare it with the standards and what actual concentration exists. So all sort of uh, you know uh, discussion is and all sort of this study and all sort of analysis, it comes under air pollution management. So also it involves how the air quality it impacts the public health. What are the costs uh, involved in reducing the concentrations of pollutants, and if they are emitted, what could be the cost of public health, because if you are having some diseases because of this uh, pollutants, then what hospital charges, what are the treatment, and what would be its cost, uh, and so on. All such sort of uh, you know analysis needs to be done, which comes under air pollution management. Then coming to emission inventory. So it is a sort of database that includes the data of source and the amount of air pollutants discharged, along with what could be the probable health impacts of uh, the pollutant which is present in air, right? So emission inventory, it has various volumes, right, which gives you idea of different category of pollutants, different sources, and different amounts, right? So first volume, it includes information on the sources, methods for estimating emissions, and procedure to maintain and update the inventory. So it gives the overall or general idea of what could be the sources, right? What could be the estimating emissions, method for estimating emissions, what could be the procedure to control the emission, and so on. Then there could be some multiple sources. First could be point source. Now, point source is nothing but from where it is originating. So there will be only one location from which it is originating. Say, for example, industry, you can, if you know that this industry is emitting uh, air which contains arsenic, right? So that is a point source. You will not allow that air stream to mix with another, right? So if you know the source, it will be very good, right? Like you will be able to um, uh, reduce the mixing into further streams, or you will be able to reduce the spread of pollution. So you are able to identify the point source, then you collect the data, what is the uh, emission out of it, and then you analyze the data, and like then you can think of further strategies. Then there could be some area source, uh, right? So from a particular area, if you are getting the emission, then that is nothing but area source. And similar emission factors, calculations, data analysis, all it is done for area source, which comes under volume 3. Then if you have a mobile source, then all sort of calculations and data analysis for mobile source, it comes under volume 4. And last but not the least is the reference related to all, which might be related to any of these analysis and data interpretation. It comes under volume 5, which is nothing but bibliography. Now this word itself is the meaning references, right? Yeah. So uh, now moving forward. So air pollutant concentrations, they are measured in various forms, and this has been talked earlier also in the previous classes, where it could be 8 hours, it could be 24-hour based, annual based, and certain air quality standards are also maintained by government. Now, to maintain the standards, uh, you need to either have some remediation technology, or if it is uh, below certain hazardous level, then up to certain level, the environment or the atmosphere has inbuilt cleansing properties, which includes dispersion, flocculation, absorption, rain washout. So can you tell me what is dispersion? Okay. So dispersion is nothing but it because of the concentration gradient, uh, the molecules or there is molecules transfer from one place to another from high concentration to low concentration. So, along with the bulk movement, which is because of the wind, okay, so that is nothing but dispersion. And flocculation is nothing but precipitation because of the formation of flocks, which are nothing but bigger particles. So, small particles they convert into bigger particles, and bigger particles are easier to settle. So, for example, particulate matter, okay, if they are able to form flock and they are able to settle, then it will not harm our lungs, right? Then absorption and rain washout. Okay, so some gaseous pollutants they have the tendency to get absorbed in rain. They have the tendency, uh, particulate matter, they have tendency to settle along with the rain. So all such sort of mechanisms are nothing but inbuilt cleansing property. Okay, so this all these will reduce the pollution. Now, further task to reduce the pollution would be to reduce at the source itself, where you use low sulfur containing fuel because emi- using sulfur containing fuel it results into SOx emission, which might be causing pollution of SO2 and so on. Then you might modify the process and you might have better equipment maintenance and so on. Then if you talk about vehicular emission, then required for existing vehicles to reduce emission, control emissions per vehicle mile traveled, right? So vehicles are one of the most important source from where the air pollution is created because the fuel which is burnt, it is combusted, it emits various gases, it emits ash, which results into pollution. Okay, so to reduce emission in from vehicles, there are guidelines made, there are provisions made by the government, which is targeted towards reducing the emission. Now, for that, how can it be done? So, that can be done by providing guidelines to the manufacturers to use a certain type of fuel to manufacture, uh, the vehicles which has certain guidelines. So, right, so there will be guidelines provided by the government so the vehicle which needs to be newly launched, okay, so that vehicle needs to pass a test in terms of pollution generation, right? So how much pollution it is generated. Further, um, as as the vehicle gets older, its efficiency reduces and the chances of pollution increases. So the government has further made the guidelines to have the usage of a vehicle with up to a certain limit. Okay, so and send it to scrap once it is used for a particular amount of time. For example, for two-wheelers, government has made a provision to send the vehicle to the scrap after 15 years so that it creates lesser pollution, right? So similar guidelines are available from the government part. Then other guidelines could be what could be the emission amount of emission similar to wastewater for per industry, what would be the amount of pollutants it can discharge into water bodies, and what could be the maximum amount of wastewater generation? So similar to that, per vehicle and per mile traveled by a vehicle, what could be the amount of emissions it can maximum allow? Okay, so maximum allowable emission per vehicle mile traveled. So that also uh, is another way or another strategy of reducing vehicular emission. Yeah. So now, in planning all the, you know, uh, in planning all these steps, so you need to consider uh, if the air pollutants are emitted and they are now creating some health impacts. So this also uh, comes in one of the major important step of planning or air quality management, air pollution management, where you consider uh, if the pollution exists, then what is the cost of, for example, because of air pollution, you end up having asthma, right? So, what is the to uh, cost of medicines, cost of uh, dealing with asthma, right? So in that case, you need to encounter this, whether all which whether all the common public they are able to bear that cost and how we can uh, reduce that health impact. Okay, so all such sort of analysis needs to be done. Now, to achieve these goals, government makes various provision where it monitors the air quality, right? So there are various monitoring stations nowadays. So National Air Quality Monitoring Program, under which monitors for um, measuring the concentration of pollutant. It covers 344 cities. Now it can measure various pollutants including SO2, NO2, particulate matter, and also other type of pollutants. So air quality monitoring systems are nowadays installed so that you can have an updated idea. Now this government needs to maintain a transparent website or portal on which even a common public, a citizen can look into um the values of air quality, like the values of pollutants which are present in air, so that they are also able to get aware of where they are living, right? So under this program, and further here the provision is such that it measures at a particular instance, right? So, and that is reported. So there is no continuous measurement. While in case of continuous ambient air quality monitoring systems, the uh, air quality systems are installed and they measure the pollutant concentration continuously, right? And those concentrations are, they are displayed on public portals so that everyone is aware of uh, the existing air quality. Now, this existing air quality, it further depends on the season, right? Winter, summer, and monsoon. So, seasons also govern what uh, the air quality will be, right? So, that is not in our hand, but in our hand, what we can do is we can reduce the air pollution uh, and we can reduce the emission. That is in our hand, right? So now, so once the air quality uh, monitoring systems are developed and they are installed, what you need to do, you need to have standards by which through which you can uh, you know you can compare what is the existing air quality so that uh, you can get the idea whether the pollutant level that are prevailing, that are below the uh, permissible level, or not, and what could be like whether they can cause adverse impact or not. So now our objective is to indicate the level of air quality required, establish priorities for abatement and control. So you can make guidelines and you can make a pattern which type of city. For example, metro cities will have higher emissions because of more vehicles used and so on, more better urban or more urban activities going on. So metro cities will have higher emissions. So in that case, you can prioritize the abatement and control plan, uniform yardstick for assessing air quality, and indicate need and extent of monitoring. So, for example, if you talk about Delhi and Mumbai, like such metro cities, then you would have heard that the air quality in Delhi it is very poor, right? So in that case, you will be able to get the idea of number of monitoring systems also that you might put. For example, in small cities, you might have lesser number of monitoring systems, while in metro cities, you might require more. So that you can get more and more idea of it, right? Now, not only you will get the concentrations of individual pollutant, but apart from that, you will get the idea of the overall air quality. Now, for that, there is one index which is known as AQI, which is Air Quality Index. Now, Air Quality Index is nothing but a tool to effectively communicate the air quality status to people in an easy to understand manner. Okay, so instead of looking at all the parameters, all the pollutant concentration, then comparing it with its standards, and then saying that whether the air quality is good or not. So instead of that, what you do, you have a have an index, you have a number which will tell you the overall idea of what is the quality of air. So you have different you know uh, numbers and different categories based on which you will get the idea of it. So air quality index, it includes eight pollutants: particulate matter 2.5, which is PM having size to less than 2.5 microns, around 10 microns, NO2, SO2, carbon monoxide, ozone, ammonia, and lead. And depending on the AQI, it can be classified as good, satisfactory. So there is a long list, I guess six: poor, very poor, and so on. So I'm not listing all here, but so depending on what AQI is prevailing right now, it is categorized as poor or satisfactory or good uh, air quality, right? So now, how do you measure the AQI? So there are various mathematical uh, ways of calculating air quality index, and depending on the country and depending on the uh, region, there are various methods of measuring this air quality index. And you might have some different name also to this, which might differ slightly, but not the name might differ, but the meaning will be the same. Okay, so uh, let me give you an example. Okay, so if you compare particulate matter PM10 and if you compare it with O3 and PB, let's take example of these three. Now, each of these pollutant will have different toxicity and impact depending on concentration, right? So, it might happen that lead might be more toxic at lower concentrations as well as compared to ozone, right? So, depending on the concentrations, the toxicity amount might be different, right? So, you need a parameter that gives you the idea of, uh, what toxicity level it imposes. So that is nothing but a sub-index I, which is calculated or which is uh, available for each of these pollutants. Now, depending on the amounts of, so this is a parameter which you will know for each of the pollutant. Now, this is, uh, you know, per unit pollutant, or it is a normalized uh, uh, parameter which does not, it does not include the concentration, right? So, uh, just a second. Uh, so, in order to do that, the amount of pollutants present in air would be different at different times. So, what you do, you take the weighted average of this I. So, WII. Okay, so for all the pollutants, you take the weighted average of this I, which will give you a number which is nothing but AQI. Now, this is nothing but an operator over I which you have followed, which is one of the way is weighted average. Now, another different ways you can have is maxima operator. So you identify the pollutant which has maximum I, and that will govern your AQI. So depending on the region, you have different ways of identifying AQI. Uh, now, so you do weighted average, weight, so WII for each of the pollutants. So the one which will have highest I, it will determine AQI. So that is the method which is followed in India. While you can have look into what other countries and what other regions they follow uh, for AQI measurement, right? Yeah. So is it clear so far? Okay, so now let's move forward. There is only one class of pollutant which is left we need to discuss. We have so far discussed about air pollution, wastewater, water pollution because of wastewater generation, solid waste, sludge management, all sort of waste we have discussed. Only one category of waste remains which requires special attention, which is nothing but known as special category waste. So any kind of solid or combination of solid waste that due to its quantity, concentration, physical or chemical characteristics require special handling and disposal, they are nothing but categorized as special waste. So now in under this classification, there are two types of categories. One is biomedical waste and another is e-waste. Give me a moment. Yeah, so let's start with biomedical waste. And what waste comes under biomedical waste? Can you tell me what waste are biomedical waste. Yes.
I think needles and I mean the I get disposable syringes and all.
Yeah, you are right. So, needles, syringes, then other type of biomedical waste could be, after during treatment, there would be blood loss, which goes along with some waste stream, right? So anything containing blood, anything containing some sort of skin, hair.
So gloves and all mask, all of that also.
Yeah, 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 yeah. That will also come under, uh, uh, you know, biomedical waste. So let me give you an example. If you have war during corona virus pandemic, you used to wear a mask, right? So instead of having proper disposal of mask, would you prefer mask touching others' mask and handling it like very casually? Would you do that? No. So
No, no,
yeah, that requires special care because if you have sneezed or if you cough, the virus, the bacteria, uh, it uh, it will be there with the mask. If you are using gloves, it will be there with your gloves. So that also requires special care, special disposal, and special storage because this all these type of waste they can easily spread diseases, right? If I give you another example, then injections that you take, then that needle is always discarded immediately, and that needle is also one time used because if there are by chance also if that needle uh, gives pokes you, then it will create diseases in your body. So, and every person has different immune system. So in that case, special care is required for handling biomedical waste. Okay, so here the examples waste generated from hospitals containing infectious material. This also comes under biomedical waste. So if I give you an example, so any uh, thing which contains blood, which contains biological or microbiological culture, um, like why culture? Because it adds up into the growth of microorganisms and which can further spread disease. There could be some body parts, bandages, etc. Right? Now, it can be categorized into two types, non-hazardous and hazardous. Now, non-hazardous could be from administration, hotels, stores, restrooms, etc. And no non-hazardous, you can give some minor treatment, and then you can say that they do not will sorry they will not create further pollution. So you can dispose it off. While in case of hazardous, you need to take further care so that it will have minimum impact on uh, human beings. So hazardous waste can be obtained from ICU, labor room. So any treatment where there will be gloves. Okay, so if a doctor under is doing operation of a patient, then gloves might be covered with blood. So those gloves also need to be taken care of very properly, right? So treatment room, dressing room, etc. So to deal with all the types of waste, which are nothing but categorized as biomedical waste, you need to have a proper plan, which will so that it will have minimum environmental and human health impact, right? So So how to do or how to manage all these types of biomedical waste? So for that, there are different steps which needs to be followed. Um, okay, so first and foremost thing is to have a proper collection strategy for each type of waste, right? So depending on the type of waste, you need to have proper collection systems. For example, if you have syringes or if you have needles, now needles and if you have sharp blades, if you need to collect such waste, then they might easily cut anyone's skin. So those needs to be collected very properly and also further stored properly. So you need to have different color coded containers. So the material of container also needs to be decided based on the type of waste you are dealing with. Okay, so if you are dealing with gloves, then you might have another container, and if you are dealing with disposing of needles and blades, then you need to have different containers. So different color coding is provided so that depending on the type of waste you are generating, you dispose it off in that respective container. Now, there are rules obviously prevailing, but what we can do, we can efficiently follow that rule so that we can have least impact uh, further, right? Now, uh, for collection also, you need to have segregation at source. Uh, why segregation at source is required? Because the waste might have different properties and different ways of dealing with, different ways might be required to deal with. So in that case, what you can do is you need to have separation or segregation uh, of all these waste at the source itself so that it will be easier further to uh, you know handle them. Now further so depending on the source, they can be categorized depending on the type of waste into these many categories, which uh, and what uh, you know what are its composition, and depending on that you can have the segregation at the source itself. Now to dispose this waste or for further management and treatment, you might not have any you might not have any facility of handling that waste in the at the source itself or at the point of generation. So you need to store it, and also it might not be feasible if you have a facility to deal with that waste or to manage that waste. It might not be possible to have immediate generation and conversion treatment, right? So for that you need to have a storage. So for the storage in a separate room, in a separate building will be required, and proper material of construction of the storage tanks are also advisable to be followed properly so that there is no leakage, there is no cuts obtained because of sharp materials. Okay, if you are using some plastic material or plastic bags to store the waste containing sharp materials, including needles and blades, it will cut and it will fall down. But you can use plastic bags to store gloves and so on. So storage is also an important step here. Now, next thing is the transportation, because as I mentioned, the treatment facility might be installed in the facility or at the source itself, or it might not be installed. Okay, so or further, if it is there in the premises itself, it could be at some different location. So on-site transportation, where you have some treatment facility inside the premises only, and off-site where you have some different place for treatment. Okay, so now last step is once you have transported, you need to treat it and dispose it. So there are various ways of treatment uh, depending on the type of biomedical waste. So one of the important uh, treatment step is incinerate, where and plasma are where you are destructing or where you are if there are some organic contents. So you are converting it into final inorganic matter, which is least hazardous or which is not uh, having any property to further contaminate, right? So, uh, for example, you have body parts, you have dead animals. So, all such sort of waste can go for incineration. While there are labs also, for example, if you are discovering new drugs, if you are having uh, microbiology experiments in the research labs. So for that, what you can have is different strategies to disinfect at the source itself, where you can have autoclave. So autoclave, it uses steam at high pressure and high temperature, which is able to kill the microorganisms which are present, right? So it will uh, stop the further infection. Uh, Now, high temperature and high pressure, these microorganisms do not survive. So that is why you provide high temperature and pressure. Now, for this autoclave, depending on the temperature and pressure, uh, there are already prescribed values of what time you should provide for autoclave to be done. Okay, so that complete killing of microorganisms are obtained. Then you can have hydroclave where you know uh, certain uh, while where when you are using autoclaves, what you are doing, you allow the temperature to rise and pressure to build up, and you allow it to cool down, and whatever you have autoclaved, you can take it out. While in the case of hydroclave, what you are doing, you are not allowing it to cool, you are maintaining a certain level of higher temperature so that energy requirement is lesser at every step. Then you can have some chemical disinfection, for example, chlorine, calcium hydroxide, bleach, etc., which have the ability to generate radicals and some reactive species which can penetrate into the DNA or which can damage the DNA of microorganisms, and that is how it kills the microbes, right? Next is microwave based uh, disinfection, where you are using wet waste. Now, this wet waste, if you have, then they have the moisture in the pores itself and in the inner side of the solid, right? So now when you provide microwaves, it increases the local temperature and it generates steam, which is having high temperature, and inside the pores, it will have high pressure as well. So that steam is having the tendency to kill the microbes which are present. Okay, so microwave, it generates high temperature and pressure in pores, which generates steam and which in turn kills microbes, right? So this is how it works. And lastly, whatever the material, like there will be some solid content obtained after incineration, there will be some disinfection provided solid content which you might send to landfill sites. Okay, so these are nothing but the treatment steps. And land disposal and deep burial, they are two types of disposal strategies you might adopt. Now, this was about the uh, uh, biomedical waste and its handling. So, is it clear so far to you all? I assume it is clear to you all. So, let's move forward to another type of special category waste, which is e-waste. Okay, so e-waste is the short form for electronic waste. Okay, so this generation or in our age, we are dealing with at every step, and when we wake up till we sleep, we are dealing with number of electronic items in our daily lives, which include uh, mobile, laptop, uh, then watch, then earphones, and there are n number of things. Okay, it will not end. Okay, and at every place. Okay, so not a single person nowadays it is not dealing with any electronic item. Okay, so it uh, e-waste management includes the waste which are generated from electronics and electrical materials that needs to be discarded. Okay, so it is composed of usually organic, ceramics, inorganics, and so on. So if I give you an example of mobiles, right? So mobiles will have different material for uh, you know body, right? So body will have different material. Then if you talk about display, then display will have some glass material or some different polymeric material, right? Then if you this mobile also has batteries, which are another electronic waste, right? So every step you will have certain uh, electrical components which needs to be taken care of. Um, Right now, for example, remote also is an electrical component where another electrical component which you are using is battery. Okay, so the sources of these electronic waste could be computer, speaker, printer, TV, CD, DVD, mobile phones, landline, oven, washing machine, battery, etc. So, yeah. So it can be composed of various materials. Okay. So as I mentioned that it can be composed like body of mobile will have different material, then display will have different, then battery will have different components. So what could be the constituents of e-waste? So it can range from precious metals including gold, platinum, silver, palladium, etc. Then it can have useful metals including copper, aluminum, iron, hazardous metals like mercury, etc. And other than that, it can have high impact polystyrene, polycarbonate, glass, etc. Right? So all such sort of components they constitute e-waste. Now health impacts. Okay, now, if we dispose it randomly, then health impacts due to certain hazardous components, including heavy metals, could be damage to blood, kidney, central nervous system, etc. And if we talk about the environmental impacts, then it affects the land and sea animals. Further, if we talk about other disadvantages of um, disposing the electronic waste casually, then it includes data security as well. Okay, so if your mobile is uh, not working, say for example, it has a lot of data, your personal data, and sometime it stops working. So what you will do, you will not throw, like, you will not dispose it without deleting your data or without, because what will happen, someone might take your mobile, get it repaired, and um, your data might be uh, used up in some negative way by another person. So data security might also be a challenge if you uh, do not handle the electronic waste properly. So there are different, you know, adverse impacts depending on which. There are guidelines made for Environmental Protection Act, ozone depleting substances, then hazardous waste management, handling and transport boundary movement rules, etc., so that you can handle the e-waste properly. Now, there are different steps involved or different methods for managing e-waste and for production and for disposal. Okay, so let's um, start with these first. Reduction in production. Okay, so for that, what steps are involved is life cycle assessment. So life cycle assessment is nothing but it is the design of environment friendly device and minimize its problem. Okay, so you, by this analysis, what you are doing, you are analyzing or you are assessing the entire life from its synthesis, from its manufacture till its disposal, at what different steps it will go, and what are the different ways it will have impact on anyone who uses it or anyone around it, right? So what, from its birth, from its manufacturer till its till its um, end of use, what are uh, its probable outcomes, right? So that you assess, so that, so if you are able to assess this, you will be able to have proper manufacturer, proper uh, device control, what you will be able to think how you can minimize the problems. You will be able to identify which is the main point which creates problem, and you will be able to minimize it, right? So you identify the problem and you minimize it. Next method is multi-criteria analysis, which is a tool for considering strategic decisions and for solving complex and time-taking problems. Okay, so you are uh, making decisions and solving complex problems in case, so you are theoretically considering everything uh, which might be taking from time taking problem. Okay, so next is material flow analysis. So tool that considers flow of material and it assesses for impacts, right? So uh, where the material flows and what could be the impacts during each step you are doing the analysis, so that you can reduce it uh, by highlighting which is the major uh, problematic step. Then next is extended producer responsibility. So, for example, if I give you uh, the example of mobile phones or laptops, then the product designer or the manufacturers, to reduce the toxicity, they provide the guidelines or they are responsible for after its usage what will be the way of disposing it, right? So that comes under extended producer responsibility. So it is the responsibility of producers to provide the guidelines to have proper disposal of the waste which is generated, right? The next is if the waste is generated, then you try to repurpose and reuse that electronic waste. So if we give the example, then if you are recovering the plastic electronic waste, then you can use it for making slippers, then vineyard stacks, etc. Then if you are using recovering any sort of metal, then you can use it for steel manufacturing, other metal products, etc. Then mercury, if you are recovering, then you can use it for dental amalgams, fluorescent lighting, etc. Then you can use it for battery, etc. or to make alloys, etc. So there are different strategies by which you can recycle this waste. Okay. So first, if we talk about hydrometallurgical method, so in this method, what you are doing, okay, so acids have the tendency to dissolve anything. Okay, so it dissolves different materials, but the rate of dissolution will be different for different materials. Now, if we talk about metals, then they are easy to be dissolved. Okay, so what you are doing, you are extracting the metals which are present in the electronic waste by using strong acids. And okay, so what you are doing, you are segregating, you are separating, you are recovering the metals which are present by using strong acids. Now, once you have done that, you can recover these metals and you can use it further. Okay, so recovery can be done through some electrostatic precipitation, electro refining, cementation, etc. Then other method could be pyrometallurgical method, where you provide incineration, smelting in blast furnace to recover and to separate non-ferrous and precious metals. Next is biometallurgical method, where you are using instead of strong acids to recover metal, you are okay. So plant have natural reducing agents, they have natural oxidizing agents, they have natural agents that can extract material. Okay, they can extract metal. So you are using plant-based products, you are using microbes, okay, that and if you put it with the waste, then it will have the tendency to extract, it will have the tendency to leach out the metals out of it, and that is how you separate the metals from the electronic waste. Okay, so that is it about the electronic waste, how you recycle and reuse the electronic waste. Okay, so now let's move forward with the sample assignment. Uh, can you give me a minute? I will just be back. Start again. The first question is which of the following process is not an inbuilt in the atmosphere to clean itself? Okay, so if I list down the uh, self-cleaning ability to in the atmosphere, so different mechanisms involve dispersion, flocculation, absorption, and uh, rain washout.
Qualification.
Yeah, correct. So qualification is not uh, the self-cleaning process of atmosphere. Next is which of the techniques is used in industry to control particulate pollutants? So for particulate matter, um, let's look into the options which we have. So we have fabric filter, combustion, absorption on solid. Okay, so you use fabric filters to separate material based on or anything based on size. Okay, so anything can be separated based on size by providing a fabric, as a filter media. Okay, so particulate matters, they have very different size from the air molecules, and which might be separated by fabric filter. Sorry, not might, which can be separated using fabric filters. Now, if we let's so fabric filter is the correct answer, but let look into the other options. So combustion, if we talk about, then combustion is used for anything which contains organic. Okay, so if there is some organic content, then it can be combusted to convert into carbon dioxide, monoxide, or some uh, uh, other uh, carbon monoxide plus hydrogen, so that you can have some you can utilize that gas. So combustion is provided for the organics, while adsorption on solid is used for gaseous pollutants which have some ability to interact through physical and chemical forces. So it utilizes physical and chemical forces for separation. So, yeah, correct answer is fabric filters. Next is the calculation of green index included the sub-index of two variables, which is you can look into the lectures, and it is uh, a very theoretical question, which is nothing but SO2 and COH, right? So let's move forward. Which of the following is not a source of hazardous waste? Now, hazardous waste, let's look into the options. Anything which will create some toxicity will be hazardous waste. So, radio imaging ward. Okay, so if you talk about radio imaging ward, then this wards can generate waste which might have radioactive material. So, this is one of the type of waste. Okay, so most probable waste, radioactive materials. Okay, so this can penetrate the skin and cause cancer. So one of the most toxic material or one of the most hazardous materials which are present. So this is hazardous waste. Then dressing rooms. Okay, so these are nothing but biomedical waste. Uh, okay, which will be generated. So dressing rooms also, they generate hazardous waste, so that is also a source of hazardous waste. Then operation theater, similar to the above one, generates biomedical waste which can be uh, hazardous, while restroom will not generate hazardous waste because it will be all organic, which is biodegradable. So urine and all, they will be uh, not non-hazardous in nature. So correct answer is restroom. Next is correct sequence of steps involved in the management of medical waste is dash. So what you do, let's write down and match letter match with the option. So first you collect the waste, then you segregate the waste. So okay, so collection and segregation, they are sort of, interlinked. When it is collected, you either have different, for example, if you are uh, in a hospital, then you will have different dustbins or different bins for different waste. Or once it is collected, then also you can segregate it, but it is better to have interlink of both. Then once it is segregated, you will store it and transport it to the facility where it's treated and handled. So transported to the treatment facility where it is treated, and lastly it is disposed. So these are the steps. Now you match it and tell me the option. So first is collection, segregation, storage, transport, and treatment and disposal. So A, right? Which statement is not true about the segregation of biomedical waste? So segregation refers to the basic separation of different category of waste. So this is a correct statement. Segregation is the easiest step. Segregation reduces the need of special handling and treatment. And effective segregation can ensure the effective management of biomedical waste. Yeah, so if you talk about the one which is not correct, then easiest step. It is not one of the easiest step. Because, right. While if you look into the other options, then it reduces the need of special handling and treatment because uh, depending on the waste, the special handling and the treatment might differ. So it reduces the load, okay, on handling and treatment. Further, it ensures the effective management, right? So it is not the easiest step. It is difficult to segregate, while others are correct. Other options are correct. Now, if not value, it provides the lethal equivalence between expected and practical conditions for autoclaving and can be expressed as dash. So it is nothing but a parameter, okay, so which gives you the estimate of expected uh, lethal equivalence and to what is existing. Okay, so uh, the correct formula for that is, so it relates the time provided, it relates the temperature difference, and based on that, it gives you a value of what could be the percentage death of microbes. So this is a formula which is A. So you can look into the textbook and you need to remember this formula. So yeah, A is the correct answer here. Next question is identify the steps C and D involved in the recycling of e-waste. So first it is collected and transported. Then to manage it, it is shredded and sorted. So next is the dust extraction, right? So whatever might be the dust present, that is extracted. So C is dust extraction. Then any sort of magnetic materials, because batteries and all, they have magnetic properties. Then metal bodies also. So magnetic separation. Then D is any sort of water content, if it is present, then water separation. So D is water separation. Purification of waste stream. Okay, so once you have collected water, you purify it and prepare the recycled material for cell. So C here is dust extraction and D is water separation. Next question is methods used for metal recovery from e-waste includes hydrometallurgical, yes, where you use strong acid. Pyrometallurgical, where you use pyrolysis and extraction. And some microbes in or plants in biometallurgical process. So all of the above is the correct answer. Now, last question. The ambient concentration of CO2 in a city is 500 ppm, which is volume by volume basis on a particular day. Now, express its concentration as milligrams per liter um, of air. Assume STP. So what you are given a concentration which has some basis volume by volume. So volume by volume is nothing but volume of CO2 per unit volume of air, right? Now this is volume by volume definition. Now ppm definition is nothing but parts of pollutant or any part per unit million parts, okay, of anything. Okay, so per unit million parts. So here ppm of CO2, so parts of CO2 in 10 to the power 6 parts of air. Okay, so if we talk about volume by volume concentration, then we can expand it as 500 uh, liters, for example. It will be present in 10 to the power 6 liters. Yeah, so that will be the definition uh, of this ppm. So if we take a unit volume of air, so 1 liter of air will have 500 into 10 to the power minus 6 liters of CO2. Okay, so now you need to find out if this much volume of CO2 is present, what will be the moles or the milligrams of CO2 in that 1 liter of air. So you need to just convert this liter into milligrams. Okay, so first what you can do here, the hint is given to you is STP conditions, right? So this means that you can use sorry, sorry, ideal gas law, where you can convert volume and pressure into uh, moles, right? And later you can convert moles into weight or mass. So what does ideal gas law state? PV equals to nRT. So N is number of moles of CO2, which is nothing but PV by RT. Okay, so standard temperature and pressure condition means temperature is 273 Kelvin and pressure is 1 atmosphere, which is 10 to the power 5 pascals, right? So it's better to have units in SI unit. So it will give you moles in kilomoles. So 10 to the power 5 Pascal into 500 into 10 to the power minus 6 liters. If you convert it into meter cube into 10 to the power minus 3, you need to multiply divided by 8.314, which is the value of R at standard temperature and SI unit into 273 Kelvin. So multiply all this and tell me the value. So it is 2.2 10 to the power minus 5 kilomoles. Okay, so number of moles will be nothing but 2.2 into 10 to the power minus 2 moles. Now to find out the weight, uh, multiply this with 44. Okay, so weight equals to 2.2 into 10 to the power minus 2 into 44, which is gram per mole. Okay, so this will give you gram, okay, which is zero point 0.9 around, so 0.98 grams. So this much gram is present in 1 liter. Okay, so if in gram per liter it is 0.981 gram present in 1 liter of air. Okay, so this is the calculation. I hope everyone has uh, understood.
Yes, ma'am.
Okay,
Ma'am,
okay,
just 1 second.
okay.
Uh, uh, Ma'am, can we end the class today a little early? Is this the last class, ma'am?
Yeah, this is the last class.
Okay. Thank you, ma'am.
Okay, yeah, yeah. If you don't have any further doubts, we can end this class now. I was
Yes,
about
ma'am.
to end. Okay,
Yes,
okay.
yes.
Thank you.
Thank you, ma'am. Thank you for teaching.
Thank you for joining. Thank you for being the obedient student.